Welcome to Inspectioneering's latest webinar, Auditing My MI Program. It's brought to us by Siemens Process Safety Consulting. And my name is Greg Alvarado. I'm the Chief Editor for Inspectioneering. Our presenter today is Mr. Reuben Laurel. Mr. Laurel is an experienced mechanical integrity professional with more than 15 years experience as an MI lead and more than 30 years overall experience in the maintenance area. Mr. Laurel is an expert in ultrapipe and PS-AIM applications and various aspects of the MI compliance program. He has advanced knowledge in ASME, ANSI, NBIC, and API codes and standards, and has been a certified API 570, 653, 510, and 580 inspector and an AWS certified welding inspector since beginning in 1995. After the presentation, Siemens will briefly talk about their services. After that, we'll end with a Q&A session, and please submit all your questions and we'll do our best to answer every single one of them.
Thank you, Greg, for the introductions, and thank you everybody for joining us today for this webinar. The outline of our presentation today would cover an overview of the Mechanical Integrity Program and of the audit, the purpose of the audit, the adequacy of the audit staff, audit presentation and planning, the audit items, documentation and reporting, and follow-through. In this presentation, when we talked about mechanical integrity, we refer to the whole framework, systems, and processes formulated and integrated to effectively eliminate or mitigate the risks of equipment failure and loss of containment, improve safety in the workplace, maximize equipment life, manage equipment costs, and comply with the PSM regulation. As we know, the following activities that I'm going to mention here below do not constitute a compliant mechanical integrity program as others seem to believe or we used to believe, such as inspection and corrosion monitoring alone by itself will not meet compliance. Implementing an inspection data management system will not meet the goal. Occasional fitness and evaluations and re-rates are good, but by themselves are lacking in complying with the mechanical integrity program. Employing maintenance strategies such as reliability-centered maintenance, preventive, predictive, or proactive are all good programs and will help in the full implementation. But the main core of a good and successful mechanical integrity program is by implementing the framework coming from the Process Safety Management, paragraph J, the mechanical integrity section of the code. Just to give you a reminder, refresher of the sub-elements of this framework, it starts with J1, which is to identify all those categories and types of equipment that are covered under the PSM law, and they are the pressure vessels, storage tanks, piping systems, relief devices, instrumentation controls, including your emergency shutdown systems, interlocks, and of course, rotating equipment. So those are basically the 6 categories of equipment in a covered process that needs to have mechanical integrity implementation or included in your program. The second is written procedures. These are for conducting the maintenance work, to set up your mechanical program, and many other things that are included in the successful implementation of a mechanical integrity program. You will have instructions, checklists on how to inspect equipment, on how to document. The whole sub-element of the mechanical integrity have to be included in a written program. There has to be a written program, and all the supporting workflows, systems, processes also detailed in the program. So that's a second requirement. J3 talks about training our people, especially in the maintenance and inspection group, about the hazards of the process and all these maintenance activities that they're about to perform in order for them to be compliant with our procedures and practices and safety culture. And then J4 of the framework talks about inspection and testing. So there has to be inspection plans, scheduling, documentation requirements in the code, and there has to be a basis of your scheduling on the frequencies and the scope of inspections. And then there's the fifth, sub-element of mechanical integrity is the equipment deficiencies. So when we do inspections, we're going to find problems, and some of those findings have to be tracked, and they may not be actually deficiencies at the time. They're just findings that we need to monitor to make sure that we understand the damage mechanisms and that our tools of inspections and methods are effective for us to be able to predict and evaluate these indications and observations if they actually are defects. So, and if they are defect, their requirements under the equipment deficiency paragraph that they need to be addressed by shutting down the equipment or have a fitness for service assessment before you can return the equipment back to service. And J6 of the mechanical integrity law talks about quality assurance. So when we build a vessel, there has to be all this process safety information from the design and the calculations and quality controls, testings, NDEs, and all of that. So most of us do a good job with new fabrication. We have all this data usually, but it's probably in the repairs of our equipment in the plant that I feel like there's been lacking when I was a mechanical integrity lead, like doing a QA/QC on a repair, replacing a pipe section, not just for fixed equipment, but also for all the other categories that are mentioned that are covered under the mechanical integrity law. So these are the 6 elements that is the core framework of any mechanical integrity program. Of course, you can choose not to skip some of them, but you would probably find out from all the audit data coming from OSHA that eventually is going to cause some notice of violations and fines. So, and since the mechanical integrity law as part of the PSM was actually a recommendation and deliberated by all the companies and recommendations, so I believe that it is a very good place to start to build a framework and a core of any mechanical integrity program. The audit process can provide valuable information and feedback on the extent of your MI program. So you started to implement a program, but also there's a requirement in the code that you have to do an audit. And even if there were no requirements, it's probably a good idea for us to do a benchmark and see where we're at in this journey of trying to improve safety and reliability and implement a good mechanical integrity program. So the extent of the feedback from the program on how it's being followed and implemented, the effectiveness, the gaps and shortcomings, what's good, what's bad, the things that needed to be improved, changed, or updated. What are our strengths and successes that we can celebrate and re-energize the MI team. And let me just tell you about being re-energized. When my MI program was audited by OSHA and I had no violations, I have a commendation recognition from the president of the company and some monetary awards, and that would really re-energize the whole, my whole team, that we are doing an excellent job and And so it's a good thing to look at your strengths and where you come from and the successes and, celebrating those. But bear in mind that this is a continuous improvement process, and we can never rest on our, can I say, laurels, on our achievements. The next topic is the purpose of a mechanical integrity audit. The first one, I have 5 in this list that are high on my list, so I know there's other reasons why you would want to do a mechanical integrity audit. But these are 5 that are high on my list. First is to determine whether an MI program, the procedures, practices are being followed and if they are effective. Second is to provide feedback on the effectiveness of the MI team. The third is to determine how well deficiency action items are managed to closure. Next is to identify opportunities for improvement. And the fifth is compliance audit is a PSM requirement. So on the first one, to determine whether the MI program procedures and practices are being followed and are effective, what are we looking at? What are the elements that we're actually trying to measure, verify, or validate? We want to look at the written program. If it's being followed, we want to look at the plans, if they're effective, and we're actually discovering, or confirming damage mechanisms that we predicted and including our inspection plans. We need to validate the inspection frequencies, although the codes tell us that we can inspect internal inspections every 10 years, for example, for a pressure vessel. But do we really get there without any kind of incidents? So we need to validate our schedules, our frequencies, and also we need to have good documentation or reporting procedures or process. And we need to verify that the action items are actually managed effectively. So these are the things that you would look for in the program, procedures, practices, if they're followed and if they're effective. The second one on the purpose of the mechanical integrity audit is to determine, well, that's the, excuse me, I skipped a page, is to provide feedback on the effectiveness of the MI team. So we're referring to all the people that contribute, that have responsibilities for the implementation of an effective mechanical integrity program. For example, who's responsible for all the procedures, to validate them, to review them, and make sure that they're fresh when the codes are changed, when there's new effective ways of doing things, that these are always evergreen. So there has to be a person responsible, reviewing the inspection reports, managing the inspection schedules, signing off on whether we can still continue to run with a deficient equipment. Those have to be included in your, we call it RACI charts, right? We got who's responsible, accountable, communicated, informed, and those things. Those are the people that has to be included in a mechanical integrity program. So this is the team, part of the team that have high responsibilities. And so how effective are they in implementing and pushing through and helping us get to where we need to be in our mechanical integrity program? So are inspection schedules realistic and generated on time? If they're not done, why? So we verify those. Internal inspections, outage-related work, they have to be planned and scheduled on a timely basis. So who puts there in your maintenance work order system? Training certifications, those have to be done on time, and so many others. So when you look at how effective the team, these are the things, those are just some of the elements. You can probably think about so many others that you can verify and look and measure maybe. The third purpose of the audit, and I'm going to give you some areas also to think about, is how well the deficiency action items are managed to closure. All deficiencies need to be addressed on time. Remember that the requirement of J5 in the mechanical integrity law requires that if an equipment is deficient, it has to be shut down. You cannot continue to operate. And so unless you have some fitness for service evaluation or some kind of engineering evaluation or assessment that this equipment can be put in service until your next turnaround where you can do the repairs or replacement, then you need to have a plan for those. They can't just stay on your list, excuse me, and there are no action items. So that's what you need to look for in your verification. They have to be tracked and monitored when you go into your MI group, or where is this list of all these deficiencies that need to be addressed. They should be able to generate those with all the status of where they're at, whether they're completed, and whether the follow-up inspections and acceptance that they meet the code, and so on. The next item is to identify opportunities for improvement. So there's going to be gaps. There's going to be things that you maybe you've seen from the industry, from the API codes, and other practices that other companies have done, or other sites in the same company that they're doing things differently and better. So those things that maybe are not done as well in this plant that we're auditing, or your own program, then you need to be able to identify those so you can improve your process, and be more efficient. And of course, the last one always had to be included because of the requirement of the PSM code that you have to do an audit every 3 years. And the audit can be done by one person, as long as that person is knowledgeable of the process. There have to be a report of the findings of an audit, and there has to be a follow. We talked about deficiencies and findings. There have to be follow through on what to do with those deficiencies and findings. So those are the 5 basically reasons, purpose to me that are high on my list why I would need to do a mechanical integrity audit. Next topic is the adequacy of the audit staff. Ideally, the mechanical integrity audit team should include individuals who are, of course, familiar with the process, experienced in mechanical integrity and process safety management, and also have experience in audit techniques. The other criteria that you might want to consider are, you want somebody with fresh eyes. Because if you have somebody who worked there for a long time, you'll probably hear comments like, "It's always been like that," or "We always done it this way." So you already have some kind of prejudice or conflict of interests when you use people who also have responsibility to fix the findings. So just consider those when you select your audit team. The other one is when you use outside consultants, you have the benefit of fresh eyes and also experience in auditing and the audit techniques. But at the same time, you also have to think about that they're a little bit maybe deficient in the knowledge of your process and your facilities. So there's a give and take there. As far as the team size of your audit team, as I mentioned earlier, you can have one person doing the audit. And depending on how mature your mechanical integrity program, if you're just starting out and laying out, you have a written program and getting started, one person team might be sufficient to look at the success, the progress and success of the things that you said you were going to do, because that's really what an audit is, that you said you were going to do these things. and then what are you actually doing, and if you're effective. So one person audit team can do it, and 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 uh, and if the program is mature and you're doing a lot of things and so on, then you probably need 3 people. A period of 2 weeks, I think, is the maximum, as long as you determine what are the sample sizes of all the items that you're auditing. If you say, I just need to look at, say, 10 pressure vessels, or 10 storage tanks, or you have quantified and scoped out the amount of work, then you can do that. So one person, I think a maximum of 3 for extended period of time would work, depending on the scope of that mechanical integrity audit. Next topic I want to talk about are the preparations and planning. So first one is you have to define the scope and objective of the audit. Next one is based on the resource allocated for this audit. If it's a one person, if you have several people, you have to start thinking about how you're going to apportion. If you're the only one, then you can prioritize it, and you're the only one's going to do all this audit, so you can basically outline your agenda, the scope, and so on that you need to do. But if you have 3 people, then you need to apportion, and then with that group, then you would probably need each state to get together and say, any obstacles, any difficulties, things you might change assignments. You might team up to do interviews together. You might need help in auditing because you're running into things and so on. So if you have a team, then you need to keep updating, keep up to date with each other, so you can progress the audit and remove any roadblocks, take care of logistics and scheduling people, the interviews, and going out into the field, verifying equipment and so on. So that's what I mean when I say we apportion the different tasks in doing the audit. Identify on-site resources needed. This would help you to basically go to the right people, to schedule representatives of several departments and crafts to do your interview, access to the safety standards, mechanical integrity, the program, the procedures, results and inspections, compliance with their schedules, deficiency logs, all these things you will need to access. So you need to identify who to get to or who will take care of this documentation and information. Identify the facility to be included, because in some areas, like for example, you're starting out, you might say, well, I only have a pilot program. I'm not really doing it for the whole plant. I've selected this unit, so you focus your audit on this unit. So you need to be able to identify the scope and the facility that you're going to do your audit. You can obtain information ahead of time, so some of these things can be generated ahead of time, so you can be efficient. When you get there, you have some knowledge of the process or the status of different things of what you're looking at, from P&IDs, from schedules of inspection for that year. I mentioned about the list of deficiencies, all those things that you can think about that you can probably request and get those ahead of time, and would help you to schedule your interview process. You might also want to include company and corporate auditing policies. You don't want to just do a scheduled general report and then on the day of reporting you announce to everybody that the MI group, the inspections, is doing such a bad idea. I found all these things. Well, that's probably not a good way to communicate and get people energized and involved in the program. So there's probably company policy that would help you to be able to go through this these negative things that you find and discuss, communicate with the people involved, and get good information, get a progress report, because when you go to the files and the documents, they may not be there, but there's actually things that may be that are maybe in progress, and so forth. So the documentation is not catching up with what's actually happening. For example, the replacement vessel is already fabricated, but it doesn't, the documents are not in the old files because it's a new project, and so on. So whenever there are negative findings, they need to be discussed and verified and agreed upon on how to communicate it with, especially with the person responsible over those things. And also some of the things that you need to probably include are those, like we mentioned, about the good things, the strengths, the accomplishments, things that they have done that they pioneered, and not the other sides of are not doing, that you can also share with the other side. So those things usefully are could be sensitive, and they could be also helpful in educating the whole corporation, not just the people at the site. Make sure that the preparation includes verifying that all the requirements, the sub-elements of the code and the audit requirements of PSM are addressed whether it's in your checklist, in the interview process, in what you're going to review. In audit preparation and planning, I would also like to share with you this slide. It is public knowledge, and there's probably other data out there that you can search on the internet as far as mechanical integrity audits and compliance and things related to that. But this particular one is very significant. It was done by OSHA. This is the results of the refinery National Emphasis Program audit. And the reason why I want you to consider this when developing your mechanical integrity audit is that you already know, just from looking at the list, in the top 9 of this list are 4 items that are under the mechanical integrity program that many of the big companies have been found not in compliance. So it's a good thing to be thorough and include those on your list to make sure that you're not one of those that are struggling to meet compliance in these different areas. Number one of them is equipment deficiencies. And that's when we have findings from inspections that don't meet code, don't meet the design calculations and so on. It's violated the thickness. There are some damage that are not acceptable that need to be repaired. So those things need to be tracked and monitored, as I mentioned earlier. And many companies have been found not having, managed those properly. The second one here belonging to mechanical integrity is written procedures. That's J2 on your mechanical integrity section of the PSM code. Written procedures can be many things. For example, that would be, when you go and evaluate procedures and you interview the technicians or inspectors of the craftsmen and how they do those things. It could be just that the what we said we're going to do, they're doing differently. And that's probably common, not just, for your company, my company, where I used to work, but, we used to have just, we always done it this way, nothing happened, or, it's been successful and things like those. So those could be violations under J2. And of course, the obvious violation is you don't have any written procedures, you don't have a written mechanical integrity program, you don't have inspection plans, checklists, and basis of your inspection scopes, frequency. These things need to be in place. So those are violations under J2. J4, inspection and testing. There's a couple of violations under that sub-element. actually the actual performance and implementation of an inspection program. There's lots of violations, and also the documentation. And if you read the code in J4 sub element 4, then you would see that the requirement for documentation is not really that much. And I just briefly mentioned them to you. You need a tag number. What was the reason for the activity? What was the findings? Who did it when it was done? That's all the requirement in the code. So it seems pretty easy enough to be in compliance with J4, but as you can see on this list, there's many violations. If you look at the rest of the list, there's a lot of things that are pertaining to PSI. The second one, highest on the list, is equipment Raga gap, and that's also mentioned in the mechanical integrity section. Raga gap, as you all know, is recognized and generally accepted engineering practice. You got to have a basis for inspection, as I keep repeating myself. If it's an API covered equipment like the fixed equipment, we have good practices that keeps on getting better and better, and it's used. It's widely accepted worldwide, basically. But if you don't have those, then you have to be able to find the best practices in the industry, manufacturers' recommendations, or your own experience, and that's PSI information. Design calculations, PSI information, and we'll cover some more of those when we get done this presentation. The reason why I want you to see this table or chart is that for you to think about these things, that many of the industries, not just refineries, findings in the chemical NEP is kind of the same. Equipment deficiency in that particular audit comes in second. There's also many mechanical integrity violations. So use those to incorporate into your checklist to make sure that your program's sufficient to actually not only meet compliance, so you can address those things and not have an incident in your facility. So the next topic I'd like to cover is actually the audit items. So we've basically gone over why are we doing the audit, and what in the why we're doing the audit, and what are the things we're looking at in those audit elements, and what the audit staff should look like. And now we're going to go into, what are the things and how are we going to actually go over this, enormous amount of data and reports and status and process safety information for us to be able to really validate, verify, measure what we said we were going to do, that we are we have a mechanical integrity that we follow, compliant and effective, and all the tools that we were incorporating in processes and workflows are actually effective and useful for us to continue to use them, or to maybe change them and adopt new things, or give us opportunity to get better and better. So let's go into the how to go over, or what, and basically how to go over these different things that we need to audit. So we mentioned about, the first thing. Well, I'm just going to go over the list quickly first. The audit items that I have listed down here, one is the program verification. Again, talking about all those different documents that I mentioned earlier. Verify implementation, effectiveness, again, is there, and the inspections, executions, and so on. Talk about pressure auditing pressure vessels, the piping, storage tanks, relief devices, instrumentation controls, including emergency shutdown systems and interlocks, rotating equipment, the equipment efficiency, how that's managed, and of course the rest of the process safety information. So let me go some of the things that we need to look at in the program verification. And some of the things we need to really make sure that we have is a written program that is up to date. So when was the last time it was validated and verified and updated? What's the quality of the program? Does it cover all your sub-elements in the code and all the requirements of the code and all the elements, other elements within PSM that are actually connected or interface or affect the mechanical integrity program? Just like PSI from a new project, how are those incorporated into your mechanical integrity program? MOCs, when you can't buy or get the same equipment to replace an old one, so what do you do with those? There's PSI, there's an MOC process. Incident investigations, when equipment fail, how are the recommendations followed through and incorporated into our inspection plans, programs, implementation, and so on? So mechanical integrity does not stand alone. So it has, in terms of the quality, I'd be looking for those to make sure that the program is evergreen, even though the things around it keep changing, that our program has provision to pull those and incorporate those changes into the mechanical integrity program. Benchmarking of industry best practices, or what's happening around us, the changes in the codes, information like the table I showed you. There are records out there of incidents on what we can learn from them, that we make sure that that we're going in the right direction. Compliance with industry guidelines. We talked about RAGA gap. What's the basis of our inspection? So these are all verifications that the mechanical integrity program is being followed, and hoping that all these things that I mentioned about best practices, complying industry standards, complying, determining the best practices, and all these things are actually in our program. If they're not, then we probably need some help and start, looking into these codes and even interviewing your craftspeople. So this, like for example, we talk about written procedures, that there's a lot of deficiency there. Just based from my experience, what we actually had to do, we hired technical writers to interview our craftspeople so we can write their procedures. Because if you hire an engineer to write maintenance procedures, those are not probably what the people are doing in the field. So again, you have a conflict, and you're going to be found, and that's going to be, in itself is not good. So things like those that you can do to get there. So those are the things we're looking for if we're doing a new fabrication in the shop, and it's being fabricated based on ASME. Well, you gotta have design calculations, you gotta have fabrication drawings, you gotta have quality assurance of the fab shop, you're gonna have qualification. All these things have to be in your inspection, in your procedures, to be able to follow through and make sure that they're done and your vessel is fabricated in compliance with the code. So program verification, there's a lot of elements in there. I said that this program, the core of the program, has to be the framework given to us or required by the mechanical integrity code. And then the next audit item that we need to look at is the actual implementation. That we said we're going to do inspections every 5 years of all our, say, piping, and 10 years internal inspections, and so forth, or whatever we say in our program, how we're going to do inspections. We need to do what we say we do. Otherwise, we need to, upgrade our program. There's nothing wrong saying that, we're going to do it this way, but if you find a new way of doing things because the way we've been doing it is risky, or that's not really what the practice is, there's nothing wrong in changing and updating and getting better. But if we know we're doing something differently and not make an effort to really find the reason why the way we're doing it is better, then we're just asking we're asking for trouble there. Because if I can share with you, a lot of stories of incidents and catastrophes, you can probably find it yourself, because the practices, the procedures, the instructions are different than what's actually done and what is out there. So the other things that can help us verify implementation is go into the MOC documents, the incident history recommendations. The schedules will tell us our compliance. We say we're going to inspect them every 5 years. If you print a history of inspections for just say a few of the equipment, for example, you can see that there's a lot of overdue inspections that's not being done. And so those are things that can, like I said, help us verify and find out the reasons why, and also contribute to maybe the solution on how to get things done better. I mentioned earlier about, or maybe I haven't mentioned, that, for example, we have a lot of ISO drawings, right? In the small plant where I worked at, I have over 10,000 of ISO drawings, and if I have to do an inspection based on those ISO drawings, I'll never get that. So I know some people are doing what other companies are doing is actually circuitizing them. If I have a pipe run, for example, from my stores all the way to the top of the tower, I can have maybe 20 ISO drawings, but actually the service conditions, material construction is the same. So why do I need to send my inspector 20 times to inspect each ISO fab drawing when I can actually consolidate that as one inspection package? So those things, why we're not complying, the implementation struggling, we can investigate and validate and verify. And again, those things give them an opportunity, identify opportunities for improvement. So the next audit items are basically your covered process equipment. So you have your pressure vessels, your piping, storage tanks, rotating equipment, instrumentation and controls, and your relief devices. So what are you looking for in auditing these things? So you're looking for, again, process safety information, because that will determine whether we have the right materials of construction, whether the equipment is operated within their design parameters, whether the equipment materials has been replaced, that there should be an MOC. There's inspection history for these equipment. So these are common things that you look for in this audit of your covered equipment. The history of failures and actually findings from these results are very significant, because it will give us knowledge of how effective our inspection plans are in trying to inspect for, and the tools we use to find the onset of damage mechanisms. So those things are very important to make sure that we look into when we're doing audits for these pieces of equipment. Other things that we would especially look into are the new, I don't know what kind of activities different companies are doing with the instrumentation and controls in terms of complying with the mechanical integrity program. I kind of glanced into the CCPS mechanical integrity manual, and there's lots of information there on how different companies do their things. But the best thing that we've done for where the company where I came from is actually doing a functional loop check. So you're actually verifying that your alarm works. When you say it's going to alarm at, say, 80%, your high alarm is going to go off, then it should. And how do you know that? Well, you actually test them so that when you actually need them, when there's an emergency, they would actually alert you that there's a problem, and they actually work. So functional loop checks, not just calibration. That's what we used to do, is just calibrate them and say, they're okay. We actually have the work, like, for example, interlocks, have them work actually during startup and shutdown, have those interlocks, emergency shutdown systems actually tested that they work. And then you have your safety instrumented system that requires another almost functional loop check, but it covers a wider range of integrated controls that you also have to test. So these things, I recommend, if you're not moving in that direction yet, that you put that as a recommendation. If it's not in the maintenance program right now, that would be a good recommendation. So you're looking at how they're doing what they're saying they're going to do in terms of inspection, test, and documentation, and what's actually done, how they're complying, how they're meeting the schedules, what they do with the findings, the deficiencies, recommendations, all these things, and what do they extract from their experience to improve the program, and so on. So these are common things that you would need to look into and verify and measure, so you can give that feedback to your group, the company, to the group, and improve your mechanical integrity program. The other thing that I want you to look into are the MOCs, because there's always going to be many MOCs in our plants, because, well, many of our plants are old, like the one I worked at. It's probably not as old as some of yours, but we have facilities that's in the 1950s, 70s, and so on. So when we try to buy a replacement equipment, we can't find it. So you can't just buy something in the field, stick it in there, and hope it works. And so we have to go through an MOC process. And if we have problems at night, and we can find the equipment, what do we do? Then the MOC process. So we also need to look into that those MOCs are actually absorbed, integrated, and updates our mechanical integrity program, because when we do our inspections, then we say, well, we're inspecting this section from here to here. Well, that here, the other here is not there. So, where do you start? So you can have a gap in your scope because the other endpoint is not there. Or when you're doing your safety integrity level assessment, you said that the response time in one of your protection layer is gonna take your technician to go there, say in 5 seconds. Well, that isolation valve is not there because we have not incorporated that into our mechanical integrity program. So these things affect, as I mentioned earlier, it is not a standalone program. There's a lot of things that change and needs to be integrated and make our program evergreen all the time. Employee participation, I mentioned how you can actually take advantage of the knowledge of your people, the technicians who do this job day in and day out, and for them to help you write those effective and procedures that they actually do and follow. And mentioned about using technical writers, just extract them out of there and put it in paper, give it back to them. Is this what you said you were going to do? Yes, and then we validate those and approve. So there's different areas that we can include employee participation and actually make our program better. And there's a pride, yeah, we're doing it right. And there's pride in everybody when we start seeing we should see results from all this effort. Our plants are safer. Our plant don't smell anymore, because, we don't put up with leaks anymore. We said we were going to do things right. We address the deficiency. We fix it. So there's a market difference of, where you started at and the progress that you will see in the future. And so you should, that should be, those benefits should be, observable and obvious to everybody. And the next topic I want to talk about is documentation and reporting. I mentioned about deficiency in inspection documentation, but also it's very significant in documenting what we find and observe during the audit process, that we document those properly. And if there are, like I said, negative things, questions we're not sure, we need to go to the owner and actually find out, what's the status, what's going on. So we need to have this information and the agreed upon action items on what the owners need to do to implement those findings that are captured in this audit. And just want to remind you that in some cases, what I was going to say is, these are legal documents, and you have findings, recommendations that are not in compliance. Something happened, an incident happened in your site, and it's because of one of those things. These become legal issues. This is a document. This could be a problem. So if there are really stuff that the team and the owners are worried about, you might want to go to your legal department and say, hey, we got these findings, how are we going to publish it, and so on. It's not that we're going to lie, but it's just for us to be able to have plans in place that we know we have these things. These are the action items, and that's actually the next topic I'm going to talk about, is follow through. So these deficiencies and findings, not just from the equipment deficiencies, all the other stuff that we have a risk of getting into a legal situation, that there have to be action items and plans, and there has to be target dates. So we're going to put it in place. If we say we're going to replace this vessel at the next outage, there's better be ongoing motion to get that activity into your project team, your engineering team. There's a project assigned, there's budget being approved, there's a scope being developed, and so on. It's not just, it's in the work order system that, we got these findings, we wrote a work order, and we said, we told maintenance to fix it, or whoever's gonna fix it, or things like that. Well, there has to be a follow-through, completion date, status tracked or reported on a regular basis, because these are the things that actually cause failure, loss of containment, and catastrophic incidents. So just to remind us that even though the Mechanical Integrity Program, PSM, has been implemented since when? 1992? And still today, you see a lot of these incidents, and after the Chemical Safety Board's investigation, you find that, man, these guys using a float and a tag to maintain the level of this tank, and then almost the whole tank farm caught on fire because they had a spill. So you see how, things like this, so we have the mechanical integrity, implementation long time ago. There's so many incidents. If you're from Texas, probably the last couple of months, we have incident in Pasadena, Baytown, Texas, a couple in Pasadena actually, and then, after that, we had an explosion in Mexico. We had another explosion in China. So all these things are still happening. So really, we need to be serious about our program, getting it improved, learning from our experience, learning if you have other facilities that are being audited, that they have some findings and recommendations, we can learn from those and not wait for us to get audited and have the same findings. Because actually, Mr. Barab, he is the undersecretary for OSHA, right? Well, in one of his speeches, that was his frustration, that he said, we are not learning from each other because all these findings, we go to another site, another refinery, we're still finding the same deficiencies and violations. So we need to be better than that. And really the purpose is, not only for our safety, but also it's becoming to be licensed to operate. You want to expand the site? The community said, well, how can we give you permission to expand? How can we give you permission to continue to operate when you have these incidents, you have these emissions, and so on? So the impact and the value of these things that we're doing is very significant. So I've probably talked a lot already, and I just want to end it right here. And thank you so much. You can probably feel my passion because I've been in this business and done it myself, and I enjoy doing it. I enjoy helping others. So thank you so much for your attention and interest. And if you have any questions, please feel free to send those in. Thank you so much.
I want to thank Reuben for an excellent presentation. Thanks, Reuben. It's funny, 24 years ago, OSHA instituted the 1910.119 rule, and we're still struggling with it in many areas today. And Reuben, it was obvious from your presentation, a lot of these issues are systems related, process related, people related. That being said, we have a few questions now that we have time to answer and are to ask, and we ask too that please, listeners, submit your questions as well, and we'll address as many of those as we can. First question I'd like to ask Reuben is, how do organizations re-energize their MI programs? And have you seen results after your recommendations on how to re-energize their MI programs?
So the question is, how do we re-energize our MI program? It is a good idea to do an audit, because that's one of the ways that you find the progress, the successes, the achievements, the good things that you've been doing. So when you see this progress, that's one area that you can get re-energized. The other thing is really what really I guess helped our team in our site get re-energized is when you see the whole organization from the top down really confirming and affirming that we're headed in the right direction. This is what we want to do. And so everybody has freedom to really look at the way they're doing things, that they're doing it safely, that we're following procedures, and so on. For example, if one of our employees see the site manager going around looking and observing, and they don't have their safety protection, or they're about to do something that's putting them at risk, any of the employees has the liberty to do that. And they don't have any kind, well, he's the, you can't talk to him. There's freedom. You can feel the freedom. You give a work order to one of our technicians and say, hey, I want you to do this. And they know that it's a management of change. They can't just do that. They'll come back and give it back to you and say, you can't do this. So you see the culture change. You see the culture change. You see the place change. It's safer. It's cleaner. Those things, the results of having a good program and the support of the management and participation. People who used to come in meeting and they used to say, well, this too shall pass, meaning that, man, all these programs coming from top down and we're never serious. And then there comes another one. But this one here, PSM, mechanical integrity, and the support of management and everybody seeing it and they're buying into it. And so that would re-energize everybody.
We have another question from an attendee wondering, what are some of the key indicators you look at to gauge the effectiveness of the MI team?
That is a difficult question. How do you know that, the people responsible for different responsibilities for MI implementation compliance are doing their job and they're effectively doing their job? That is a difficult question. And of course, the first thing we want to look at is really the data. We look at our, let's start from our program itself. The written program is nowhere near what's actually happening, what we're doing. So who's responsible for that? Is there a reason why? Well, that's what we need to find out and interact and ask questions and not make a quick judgment and say, the MI lead is not doing his job. All these inspections are late, and so on and so forth. Well, one example that I would like to share with you is how effective was I as an MI lead and also in charge of inspections. How could I be how can I be effective when, like, towards the end of the third quarter or middle of the third quarter, all my funding was pulled out and say, you don't have any more budget for inspections. Well, how can you be effective? You don't have inspectors. You can't hardly do anything to spend money because you have no budget. So things like those. So how are they effective? You need to really find out their roles, the scope of the work, and we're all part of this team. And so when somebody's struggling and have difficulty overcoming those roadblocks for them to do their job, then the good thing to do is really to help each other, to understand, to make things easier. Communication is really a big deal in any success of any organization, because if that's not understood by others, then that program is going to suffer. So I hope I gave you some good information there, but as I first stated, this is difficult. It could be subjective, and you have to understand and be in the shoes of that person and understand why they're struggling.
Another question that's come in is, how do you determine the sample size when looking at equipment records?
When planning for an audit, you also include planning for the facility, the size of the facility that you're auditing, and have an idea of where you want to start in terms of the scope and, of course, number of records, equipment you're going to audit. So before coming to an audit, I have something in mind. This facility, there could be only one covered process. There could be several covered processes. So how many in each covered process would you audit? So you start with a number and say, okay, with this amount of equipment in the vessels, usually I start with 10. I say, I want to look at 10 in this process, and then have an agreement with the owner and say, okay, and in this process, I want to look. So, and also I would discuss with the maintenance supervisor, especially which equipment they're having problems with, having repairs and so on. I make sure I include those in the audit. Mm-hmm. So really, it's a random thing, but you got to get agreement with the owner, mm-hmm. and also for you to assure yourself that you will be able to get sufficient information for you to verify, validate, and measure.
The next question is, what areas of our work in paragraph J should we be considering procedures for? And what are some tips on achieving success and sustainability in using procedures?
Those procedures that we write should be used to train the employees that execute them, that implement them. So they should be familiar with the procedures. if you get your employees involved, those technicians that do the job, in creating those procedures, then they will be effective because that's the way they do things. They will have ownership, and it's easy for them to really critique it and say, well, we can't do this thing anymore because they just built that structure there, and so when you shoot a crane over there, if you have an incident, you're going to kill a lot of people. So things like that, when they create it, they own it, they can critique it, they can improve it, and so on. So that's one way of really being successful in utilizing, updating, and getting those procedures up to date. The other things is, again, it has something to do with ownership, and there are updates in our procedures that are actually driven by changes in the codes and practices, industry best practices. So whoever owns those really has to, if you have a schedule of all these procedures, revalidations, and it's driven by one of those base documents from, say, API 570. It has changed. Now it's requiring this. So whoever owns that and has have the expertise when it comes to revalidation, say, okay, it's been 3 years, let me look at this, what are the changes to the code? Oh, they haven't published a new code. Industry practice, anything I should be concerned with, there's nothing. So just a simple lookup and say, well, this applies. This is still the way we do things. This is the way we document things, and so on. So those procedures are, if they're owned by somebody, if they're created by somebody, people have ownership, and that's the only way that you can keep up with these things.
Thank you.
Thank you.
And we have time for one more question. And that question is, how do you prioritize audit findings and recommendations?
When we finally document, summarize all these findings and recommendations, and getting to that point, we need to communicate with the people that are affected and own these different areas and responsibilities in our MI program. Like I said earlier, we have an agreement that there's actually things to follow up there and so on. So talking to them and confirming first that these are the things we need to do. So how do we prioritize them? Well, that should be the owner's responsibility. But if I was the auditor, I'm part of the company, I'm part of the owner. When we go over that list of recommendations, the highest priority would be the ones that are deficient, and that can, if it fails, that can cause the highest impact and catastrophe. So those would be the one way of prioritizing them, and there will be some players in the company that they have production targets, they have uptime targets, and so forth, and they push the other way too. But we need. That's why we also need a written program when it comes to deficiency. We have all deficiencies that the only person that can, the person responsibility to put a deficient equipment back to service, in our case, is a site manager. So we can argue all day that, I have to meet my production target. Well, it comes to the site manager to sign off. And when the site manager says, shut it down, if you can't prove that it's safe to operate, you got to shut it down, then that's when you re-energize your mechanical integrity program, because all the employees and players and they can see, we're serious about this thing, and so on. So in terms of priority, there's input from everybody, but in my particular case, I would go with compliance first, and the impact when there's an incident, and that's also looking into possibilities of having an engineering evaluation that we may not need to shut it down. So if the evaluation says you got to shut it down, then and so forth. So there are things to do because some of our say retirement targets are are maybe aggressive, not realistic, or we know that there's a design factor. We know that the joint efficiencies of a fabrication factors into calculations. Well, where we have the defect, maybe some areas that you don't have a joint. So things like this, when considered, can also move the priority of those recommendations, in your scale. So there are things to do. There has to be input communication with different parties and see what are the engineering solutions first. And then if you can't, then it's got to be shut down. Thank you.